Bismillahirrahmanirrahim and Assalamu alaikum. So the topic that we're going to discuss today is about fermions and anions. Now, you know this universe is made up of matter, which consists of atoms, and you have studied that atoms have particles like protons, neutrons, electrons, but that's only on a minor level. If you talk on a major level, then you will come to know that there are more particles that exist in atoms. Now, here are two of them. One is fermions and anions. We're going to talk about them a little bit. We're going to get a little bit knowledge about what are these and what are the characteristics of these particles. So let's see. You can see that there's a pic. There's about the spins of fermions. There is another particle, bosons. We're not going to discuss it over here, so just look at this picture. Its spin is 1 by 2, 3 by 2, 5 by 2. You can just identify the order of spin from here. And it is like, how are they different? We're going to talk about it a little bit. You can just see, it's just a picture to make you know that how they are. They're just like electrons. Now what's the difference? We're going to talk about it. You can see in the next slide. So fermions, they're a group of fundamental particles. You know that they are the building blocks of matter. Fermions, they are related with matter. Now matter is something that has mass, that takes up space and volume. So fermion is exactly something like that, which has mass, which takes up space, which has volume. Of course, that things is gonna exist. If you talk about the division, they are further subdivided to quarks and leptons. We're gonna discuss types of fermions. Actually, we have three types. One of which is whale fermions. Now these whale fermions, they're massless. They don't have mass. They're massless, means their weight might be so less that we can consider it as massless. We have another is Dirac fermions. They're very massive. We have Majorana fermions. Now, each of Majorana fermions have its own antiparticle. What's an antiparticle? Antiparticle is similar to the original particle, but with opposite charge. Okay, it's having an opposite charge. Actually, the name of fermion, Dirac named them fermions. Dirac is the name of a scientist. Now, Dirac named them fermions in honor of the famous scientist Enrico Fermi. Now, this Enrico Fermi, he was a scientist, and Dirac named them in honor of this famous scientist Enrico Fermi. Now, these fermions, if you talk about their spin, you have seen that in previous that their spin the 1 by 2, 3 by 2, 5 by 2. That's how their spin goes. Now, if you talk about their fusion, in which way you know that two fermions, for example, you can say that those two fermions, they both have a spin of 1 by 2, can be looked at together as a composite boson. When they fuse together, when the fusion happens, when they collide, it looks like a single composite, means a single boson with total spin in superposition of 0 and 1. Now, fermion is something like an electron. The fermions, they repel each other. They are just like an electron. Like, how you can say is an electron? They transport the electricity And if you talk about boson, they are the photon that carries light, as you've seen in this picture. So you might be obvious, what is boson? I'm just going to tell you a little bit, because we're talking about fermions and anions, so we're not talking about boson, but still, I'll tell that boson is the photon. You know, photon is for light, small packets which carries light. So that was the fusion of fermions. They collided. Two or more fermions cannot coexist in space. Now that's another thing. For instance, if you can say that two electrons with both of their spins pointing up are forbidden from occupying same energy level around an atomic nucleus. So there's another thing that I'm gonna tell, that fermions, they obey Pauli's exclusion principle. It means that no two fermions can occupy exactly same quantum number. Now, in case of electron, we have discussed that too, about the first that they cannot have the same quantum number. Fermions, they are produced and they undergo annihilation in particle now, or an antiparticle pairs. Now, what is annihilation which fermions can undergo? It's a reaction in which particle and antiparticle collide and they just disappear. So it just disappears. It was annihilation, and before we studied it was the fusion. Now when two fermions fuse together, it gives a boson. And this annihilation, they both are both different concepts. They don't just mix them up. Okay, so that was for about fermion. I think that's a little bit enough for the information for fermion. Let's take a look about the another difference, which is between fermions and electrons. So fermions, they include electron, which means that fermion is a type of electron. Okay, electron is a type of fermion. Now electron is coming inside the fermion, it's just a type. So main thing that we have is fermion, and further it has types in which electron is the one. So both are obeying Pauli's exclusion principle, that both cannot have four sets of quantum numbers. This is just a minor information about the difference. There is much detail about them that we will discuss in another video maybe. So let's go to another thing that we have is anions. Now you can see here that scientists proved actually anions' existence. It wasn't sure, it was discovered very late. But scientists proved their existence, the third type of particle in the universe, which is called anions, which only arises in two dimensions. So, anion is a particle which can only exist in two dimensions. If you talk about one dimension, three dimension, it cannot exist in those dimensions. It can only exist in two dimensions. If you don't know about dimensions, it's actually the cartoon movies that you see. There are different types. In 3D dimension, you can just see a real picture, like the pictures in our real life. They're 3D structured. They have a cubic shape. They have all the four sides in a form that you can see that it is that much thick and thin. But in 2D or 1D, you can just see a front page. You cannot see the backward resolution, or you cannot see the side one. It looks a little bit fake, but in 3D, it gives you a real presentation of how the image looks. And you know that scientists cannot just stay for not doing anything. They're here to discover the things. And this universe is full of mysteries. So we cannot just say that this universe have nothing. It has a lot, and scientists are there to explore them. Wish to be a scientist too, but let's see what happens. Because exploring things really makes us more knowledgeable. It's in Quran too that you have to see, you have to search for what is in this world, and scientists are doing that. You can see a visual, you can just visualize a pig over here, which scientists prove. Now, it's just an illusion. Fermions and Anions, they're just the smallest particle to visualize. It's just an imaginary pig. Now, this picture is showing the wave, optical wave name, that how it goes, and this color spectrum, which we're gonna see in our next slides. But before that, you have to make sure that these anions, they existed. They are the third type of particle that existed in the universe, and that only arises in 2 dimensions. Now, this 2-dimensional thing is really important to notice. Okay, now let's go. Anions is a type of quasi-particle. Now, what does quasi means? It is a system of bodies which has momentum and position. I just found this picture from the net. It was so beautiful. Those colors, they just attracted me so much that I just want to put it over here. But I don't know that anions do really look at this, or it's just a visual representation. But if I just gained my aim and I'll just become a scientist, or if I gain that much knowledge, I will make another video to visualize that what is this thing. Is it just a visual representation, or it's something real? These colors, are they just for showing the different layers, or these colors do really exist? We're gonna do something to just figure it out. Now, okay, let's go to the point. Anions, they only occur in 2D system, which means 2-dimensional system. Quantum statistics is more complicated because of the different behaviors of different kinds of particles. Now, these can be fermions, bosons. And in 2D world, there is another type of particle, the anions, which does not behave like a fermion or boson. It's having a different behavior. Okay, so from this you show that anions have a different behavior. Now, what is the history of anions? Anions have never been created, but a researcher at Ludwig Maximilian University of Munich believes that he can bring them into observable world. Alamia theorist Tassilo Kalman has developed. It's just the name of a scientist. Don't think that I'm using a very hard English. It's just the name of a scientist, and it is Alamia theorist Tassilo Kalman. Now, this person, he has developed an experimental design to bring anions out of woodwork with the help of cold atoms and lasers. Now, cold atoms are that atoms, they are maintained at a temperature which is close to 0 Kelvin. In this case, colds can be 10 raised to the power minus 10 kelvins. So this would happen to bring the anions out of woodwork. You know that fusion. Now, what happens in case of fusion? Anion can be anything between a boson or a fermion. 2 or more anions, they together, means when they are fused together, they make up a composite anion. which can possibly, composite means a single, which can be a boson or a fermion. Composite anion is said to be the result of fusion of its components. Okay, so anion is an optical lattice, as you know, as I've shown you in the previous picture, that they are predicted to exhibit a characteristic signature in their density distribution, as this was shown in over here, their optical nature, how it occurs like in vase form. So these particles, they really do have interesting characteristics, which makes us to just go deeper and deeper into them. Now, there are the alpha braiding. The characteristic features of anion is that their movements are best described by braid group. Because while braiding their roller lines, they can gain non-trivial phase factor. So they are 2D. They have this optical lattice. How they're fused, as you know about it. The history is now known to you, that the scientist whose name was that happened in the University of Maeed. What happened? Now you know, and you know it's a type of cosmic particle. So this was about anions and fermions. These are fundamental particles. They're building blocks of matter. They're related to matter, because you know that this universe is not just made, it is made up of the tiny particles. As far as you have studied, you studied till atom, electrons, protons, and neutrons, but there are many other particles that exist in this world. Something related to quark, leptons, muons, anions, bosons, fermions. There's so many particles. So slowly we'll try to discuss each of them in our next slides, slides. So make sure that we study a little bit about each of the particles. Now, one thing that we have to keep in mind is what is an antiparticle. Make sure that what is an antiparticle, because these particles, they do have an antiparticle. Now, positron is also an antiparticle of it. So you have to just make sure that what is an antiparticle. Antiparticle is similar to the original particle, but with opposite charge. So fermion also has an antiparticle. 24 different fermions are there. Now there are 24 different fermions. Now you can just come to know that what is this thing. There's so many things. Now, for instance, you can say the 2 electrons. There's a principle that we studied. It was like Pauli's exclusive principle. It was like 2 or more fermions cannot coexist in space. For instance, 2 electrons with both of their spins pointing up are forbidden from occupying the same energy level around an atomic unit. Okay, that's another thing. We're not going to go over here. That's it for today. Hope so you gained a little knowledge about fermions and anions. If you have any other questions, you can just ask in the comments down below, and I'll do my best to answer them. Thanks for watching, and Allah Hafiz.